point in a stressed body, the state of stress on two planes 45 degrees apart is as shown below. Determine the two principal stresses in megapascal. The diagram is shown here and the options are 8.24 to 0.658 and other magnitudes are given as the options. And this is a 1993 gate question asked for 2 marks. Here you can see, since there is a shear stress that is on the x phase in a y direction acting clockwise, this not because it is acting clockwise. If there is a shear stress, then this normal stress can't be a principal stress, because the actual definition for principal stress is that there should be no shear stress. So we have to find the principal stresses from the given data. For finding principal stress, the formula is that sigma x plus sigma y by 2 plus or minus root of sigma x minus sigma y by 2 whole square plus tau xy square. We know the sign convention as, if the shear stress acting is clockwise, it must be used with a positive sign. If it is anti-clockwise, it must be denoted with a negative sign. Similarly, if it is tensile, it is positive. If it is compressive, then it is negative. Okay, here we are given with sigma x and tau xy, but there is no sigma y. We have to calculate sigma y using this. So we must know the sigma n theta formula and tau theta formula. Sigma n theta formula, as we have discussed earlier, it is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. First, we must know the sign convention of sigma x, sigma y, and tau xy. As we know already, tensile is positive, compressive is negative, and similarly, clockwise shear stress is positive, anti-clockwise shear stress is negative. But we must know theta also. Theta is actually calculated in the clockwise direction from x phase. This refers to the x phase, which lies in the x direction. From this x phase, if it is calculated in a clockwise direction, that refers to theta. So here 45 degree is actually not theta. We have to calculate the other theta. So it comes out to be 135 degree. If we substitute theta is equal to 135 degree here, we will be getting this formula from this formula. Sigma n theta is equal to 135 degree is equal to 8 plus sigma y by 2 plus 8 minus sigma y by 2 cos 270 degree plus 3 sin 270 degree. Similarly, this is not the only formula to find sigma y. We can also find through the shear stress formula in an oblique plane. This is actually normal stress in an oblique plane whose angle is theta, which can be 135 degree or 25 degree, any degree. Similarly, for tau theta, any theta is sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. The same sign conventions are used. Similarly, the theta is calculated as shown here. So, using this also, we can find the sigma y. After finding sigma x, sigma y and tau xy, just by substituting here, we can find the two principal stresses. The two principal stresses are found, one by adding and another by subtracting. So I have given the general formula as plus or minus. Common data questions 2 and 3, which means the questions 2 and 3 share the data given below. The state of stress at a point P in a two-dimensional loading is such that the Mohr circle is a point located at 175 megapascal on the positive normal stress axis. From this given data, the answer is being drawn. That is, the Mohr circle is being drawn as shown here. Okay, the question is the maximum and minimum principal stresses respectively from the Mohr circle are. They have asked the major and minor principal stresses, and they have given the magnitude along with the sign, which means they have asked whether the principal stresses are tensile or compressive. And it is a 2003 gate question being asked for 2 marks. Okay, here is the Mohr circle. Always in case of a Mohr circle, the principal stresses are calculated as the distance from y-axis along the x-axis. That is, along the x-axis from y, what is the magnitude? That magnitude represents the principal stresses. Here you can see it is a point. So the major and minor principal stresses occur in this point itself. So sigma 1 is equal to sigma 2 is equal to distance from y-axis along the x-axis. So actually they have given as 175 megapascal on the positive normal stress axis. So sigma 1, 2 comes out to be plus 175 and plus 175. So it is plus 175 megapascal and plus 175 megapascal. Remember, if it is a point, all point will act. The point, along the point, all stress, normal stress values will be principal stress. As the data given earlier, we know that the Mohr circle is actually a point. Okay, the question asked here is the directions of maximum and minimum principal stresses at a point P from the Mohr circle or from the given Mohr circle which have been discussed earlier. Okay, it is a 2003 gate question being asked for 2 marks. Easily these 4 marks can be scored. Generally, if a Mohr circle is a point, maximum and minimum principal stresses lie in all directions. As you know, it is a point, there is no shear stress. So, in all directions, the normal stresses will be principal stress. Because for a principal stress, the shear stress must be 0. Okay, here in plane tau max is 0. That is maximum shear stress in that particular plane is 0. But absolute tau max is sigma 1 by 2. As we know, absolute tau max is calculated as sigma 1 minus sigma 2 by 2, maximum of sigma 1 minus sigma 2 by 2, comma, sigma 2 minus sigma 3 by 2, comma, sigma 1 minus sigma 3 by 2. So there will be, if it is biaxial, there will be sigma 1 by 2 as the absolute tau max. So from this, you can consider that all directions become the answer for this question. The figure shows the state of stress at a certain point in a stressed body. Okay, from the figure it is clear that a biaxial state of stress. Okay, the magnitudes of normal stresses in the x and y directions are 100 megapascal and 20 megapascal respectively. Here you can see sigma x is 100 because it is in the x direction and 20 megapascal in the y direction. So sigma y is 20, but it is compressive and this is tensile. Okay, the radius of Mohr's stress circle representing this state of stress is, they have asked the radius of Mohr stress circle. It is a 2004 1 mark question, simple 1 mark. So the Mohr circle being drawn from the given data is as follows. Since a sigma x is greater than sigma y, also here you can see that there is no shear stress acting. So sigma x and sigma y comes out to be the principal stresses. Which one is the major principal stress and which one is the minor principal stress? The maximum one becomes a major principal stress, which is 100 megapascal. So this is tensile, sigma x is tensile. So the center of the Mohr circle shifts to the right side of the origin. So you can see sigma 1 is greater and sigma 2 is lesser. As we have discussed earlier, that principal stresses are calculated from the origin along the x-axis from the origin. Okay, here you can see this center is calculated as sigma 1 plus sigma 2 by 2, and the other point which is the radius, which represents the radius, is tau max. The coordinates, these refer to the extremities of the diameter, or you can say this as the x and y coordinate of a point on the circle. So if it corresponds to the center point and the radius. So it is sigma 1 plus sigma 2 by 2. If it is asked as center, it is sigma 1 plus sigma 2 by 2. And if it is asked as radius, it is tau max. From the diagram, it is clear that sigma 1 is sigma x and sigma 2 is sigma y. So we know that the radius or tau max maximum shear stress is sigma 1 minus sigma 2 by 2. So here you can see it is 100, sigma 1 is 100 and sigma 2 is 20. But this is compressive nature. So minus of minus 20 comes out to be 120 divided by 2. So it is 60 megapascal. The Mohr circle of plane stress for a point in a body is shown below. We know that Mohr circle is drawn only for plane stress condition. The design is to be done on the basis of the maximum shear stress theory for yielding based on MSST. Then yielding will just begin. They have asked yielding should just begin, not should begin earlier or should begin later. If the designer chooses a ductile material whose yield strength is, they have asked the yield strength for the material to be chosen. Okay, this is a 2005 gate question being asked for 2 marks. We know that according to maximum shear stress theory, if sigma 1 and sigma 2, that is both major and minor principal stresses, are like in nature, that is either compressive or either tensile. Here you can see both are compressive in nature, so they are like in nature. In such a case, the failure criterion is sigma 1 by 2 must be lesser than or equal to tensile yield strength divided by 2 times of factor of safety, where n represents a factor of safety. Okay, here it is 100. They have asked just beginning of yielding. If we choose which material, okay. If you choose 90 megapascal yield strength material, that is a material with 90 megapascal yield strength, yielding would have begun when the principal stress is minus 90 itself. So if it is 50, when it reaches 50 itself, there will be yielding. So they have asked just the beginning of yielding should be there. So in such a case, we have to choose 100 megapascal yield strength material. That is a material with 100 megapascal. In such a case, there will be just the beginning of yielding. So the answer comes out to be 100 megapascal. A two-dimensional fluid element rotates like a rigid body. At a point within the element, the pressure is 1 unit. They have stated as pressure. Note this point. And at the same time, radius of the Mohr circle is being asked, which characterizes the state at that point. Okay, the radius is being given as 0.5 unit, 0 unit, 1 unit, and 2 units. This is a 2008 2 marks question being asked in GATE. Okay, we should know that if it is a two-dimensional fluid element and if it is subjected to pressure, then the Mohr circle is always a point. Here it is given as a two-dimensional fluid element rotates like a rigid body. This point confirms that the fluid element is not being deformed due to that pressure. So it is a rigid body and pressure is being exerted. So it comes out to be a hydrostatic state of stress. Always in case of hydrostatic state of stress, that is always in case of a pressure acting, the radius of Mohr circle is always 0. That is, the Mohr circle is a point. So B comes out to be the answer for this particular question as 0 unit. The state of stress at a point under plane stress condition is sigma xx, that is normal stress in x direction and normal stress in y direction, and shear stress in the x phase along y direction. The radius of Mohr circle representing the given state of stress in megapascal is being asked. It is a 2012 GATE question being asked for 2 marks, and the values are given below. We know that the radius of a Mohr circle is always calculated as sigma 1 minus sigma 2 by 2. That is the difference between the major and minor principal stresses divided by 2. So we know the sigma 1, that is principal stress formula, which we have discussed on several occasions in the previous videos and also in this particular video. From those formula, we can simplify this formula to this value as 1 by 2 into root of sigma x minus sigma y whole square plus 4 tau xy square. We know sigma x, we know sigma y, and we know tau xy. If we substitute those here, we will be getting the radius. Generally, Mohr circle radius calculating questions are of very direct in nature, and it is a very easy way to get the complete 2 marks. In the plane stress condition, the components of stress at a point are sigma x 20 megapascal, normal stress in x direction is 20 megapascal, in y direction is 80 megapascal, and shear stress on x phase in y direction as 40 megapascal. The maximum shear stress at the point in megapascal is being asked, and is a 2015 set 2 GATE question being asked for 2 marks. Okay, we know from the previous videos and also that is a fixed concept that maximum shear stress is always equal to the radius of Mohr circle, and the radius of Mohr circle is being calculated as sigma 1 minus sigma 2 by 2, which comes out to be 1 by 2 of root of sigma x minus sigma y whole square plus 4 tau xy square. Just by substituting here, we can get the answer, which comes out to be 50 megapascal. As I stated earlier, these questions are very direct in nature and are the easiest way to get 2 marks in GATE. The state of stress at a point is sigma x, sigma y, sigma z, tau xz, tau zx, tau yz, and tau zy equal to 0, and tau xy and tau yx is equal to 50 megapascal. The maximum normal stress at that point is, they have asked sigma max, that is the major principal stress. It is a 2017 set 2 gate question paper being question being asked for 1 mark. Okay, here you can see these values are 0, which shows that there are no normal stresses and the stress in z directions are 0. So it completely comes out to be a pure shear state of stress condition. No normal stress, and shear is two-dimensional. So it is a pure torsion or pure shear state of stress condition. In such a condition, the Mohr circle is shown here. It is actually drawn using the data given above. You can see that sigma 1, tau and sigma 2 will be having the same magnitude where the direction changes. That is, minus tau refers to anti-clockwise direction and tau refers to clockwise direction, whereas sigma 2 refers compressive nature of magnitude tau, and sigma 1 refers to magnitude tau. So it is clear that the major and minor principal stresses will be having same magnitude equal to that of the maximum shear stress acting. So the maximum shear stress is 50 megapascal. So the maximum normal stress comes out to be 50 megapascal. A shaft with a circular cross-section is subjected to pure twisting moment, which means the state of stress is pure shear state of stress. The ratio of the maximum shear stress to the largest normal stress is, they have asked the ratio of tau max to sigma 1, that is principal stress, major principal stress. It is a 2016 1 mark question being asked in GATE set 2 question paper. Okay, for pure shear state of stress, which you have seen in the previous question, the Mohr circle, from the Mohr circle, it is clear that sigma 1 is equal to sigma 2 is equal to tau max in magnitude. But however, sigma 2 is minus tau. Actually, the direction changes, that is compressive in nature. So, the largest normal stress may be compressive or tensile, but the magnitude is the same. They have just asked the magnitude. So the ratio of maximum shear stress to the largest normal stress is tau max divided by sigma 1. We know that both are having same magnitude, so the ratio is 1. So B becomes the answer for this particular question.